Hi, in this video we will learn about vector codes and how the error detecting codes, specifically check digit codes, work. Well, in the real world, when you have some information, to store the information or to transfer them or transmit them, you need to turn these guys to codes. The process, which is called encoding, basically turns different kinds of information into a very mathematical objects. Why mathematical? Because codes are vectors from Zm to the power n. Or in other words, they have n digits, so is the length of the vectors, length of the codes. And m are the digits are from Zm. In other words, any of such code, which is called code vector, say u, has digits b1, b2 up to bn, and every one of these digits up to bn are from the set Zm. Zm are the numbers in Zm are 0, 1, 2 up to m minus 1. Well, a very important example of these codes are called binary codes. They may have different lengths, but let's just say length n. So these are vectors or code vectors from, you see, binary means that they are two numbers, 0, 1. And 0, 1 are nothing but the numbers of Z2, and there are n of them, so the length of these guys are n. So you have basically codes, 0, 1 codes of length n. Remember, Z2 has only 0 and 1, 2 digits. For example, a code of length 1, 0, length 4 can be something like this, or something like, well, say 6 digit, 1, 0, 1, 1, 0, 0. Yeah. And working with these codes, the first thing you notice is that while transmitting the codes or storing them or copying them or while printing somewhere, you may make mistake. For example, someone while printing the code or copying from somewhere may write this guy as 1, 1, 1, 0. You wrongly copy 0 as 1 in the new copy. Or while transmitting, something may go wrong with wiring and you see this code as 0, 0, 1, 1, 0, 0. Yeah. So the question is there a way to detect errors occurred in the codes? Is there any way that I can, when someone sees this code, says, oh, okay, there is something wrong with this code, and we have to ask for this code again, so let them send us again. This is just detecting, okay? Or this one. Well, one of the very nice tricks that is used is called parity check code. What does it do? It says that, okay, so far you have been working in z2 to the power n. So your vectors were vector u. Now you add one digit to this guy. So basically you increase the length by 1. And if your vector was, so let me start right here. If your vector was b1 up to bn, now we are adding one digit. Let's call this guy v, b1, b2 up to bn, and then one more. The last digit is one thing that we added there, and it's called check digit. What does check digit do? Well, first let me tell you what is the check digit. So in different cases, what kind of number you put that at last spot. So where D is a number which satisfy. So it's a number that when you add all the digits you have and D, you get 0 in Z2. So if you add all of them, you get 0. Very nice. So you add one digit and that will give you something like that. For example, for the code we had up there, U. So if I have 1, 0, 1, 0, then I'll go to another vector V and we add one digit. What would be that one digit up there? Well, it should be something that when I add all the digits, we get 0. Where? In Z2. Here, 1 plus 1 is 2. 2 in Z2 is 0. So basically we have 0 plus D is equal to 0. And that means that D is 0. In other words, the parity check vector of this vector, the code vector that we started with, is going to be 0. So we replace this guy by this guy. How is this going to be helpful? Well, let's say the mistake that someone made. Now, if someone makes that same mistake, what was the mistake? The second digit, which is 0, is copied 1. So if it's 1, 1, 1, 0, 0, then the person who receives the code can say, okay, this is parity check vector, and if I add all the digits, this must be 0 in Z2. But when we add these numbers, this is 2 plus 1, 3, 3 in Z2 is 1. 1 is what we get, not 0. So that means that right away tells us there is something wrong. There is an error in this code. And that is what we have. So we implemented this technology, parity check code, and using that, now if someone copies one of the digits wrong, then you can detect that there has been a mistake. Let's do some examples for this. Paste. Okay. So find the parity check code of the given vector. So U is given. Now I want to find V, which has 1, 0, 1, 1, 1, and an extra digit, the check digit. such that 1 plus 0 plus 1 plus 1 plus 1, how many ones? 3 of them there, plus d is equal to 0. Where 0 in Z2. Here, these two add up to 2. 2 in Z2 is 0. This guy is 2, another 0. So we have 0 plus d is equal to 0. That means that d is equal to 0. So our parity check code is 1, 0, 1, 1, 1, and 0. For this other one, we have 1, 0, 1, 0, 1, and we need to add one digit. What is that digit? Well, 1 plus 0 plus 1 plus 0 plus 1 plus d needs to be equal to 0. 1 plus 1 in Z2 is 0, so we have 1 plus d is equal to 0. You add both sides number 1, and then you will get that d is equal to 1. And that is the parity check code for this guy. How about this other one? Okay, for this one, we have a parity check code, and we want to see if there has been any error in this code. So means what? Means that we need to add these guys. And check if it is 0 or not. Okay, in this case, what we see is this is 2 plus, or in Z2, 1 plus 1 is 0, then plus 1, this is 1, not 0. There is an error in this code. How about this one? Well, 0 plus 1 plus 0 plus 0 plus 0 plus 1 plus 0. And this guy, there are only 2 ones. You add up, you get 2 in Z2. Everything is in Z2, yes. Binary codes, everything is in Z2. This is going to be 0. So at least, what can I say? That the parity check cannot say anything for this one. There might be more mistakes, but what I can say that there is no single error here. No single digit error for this code. Well, if we want to generalize what we have here for the binary codes, well, we have to generalize what is happening here. And this can be done if we know one thing. Well, this is called check digit code. These are generalizations of parity check codes, which only happens in Z2. In general, we can go from Zm to the power n. If you have a vector u here, b1 up to bm, then we can add one extra digit, check digit. So we go v is b1 up to bn, not bn, and then the last digit d. And to be able to have an equation like this guy here that we had, this guy here, you see that this is where c dot v is equal to 0 for the check vector c. So we fix a check vector, and when we have a code to check if there is any mistake or not, we find the dot product of that check vector with our code vector. And if it is 0, then we are all right. But if it is not 0, it will mean that there has been a single error there. So not only we need to know this equation to find D, we also need to know what is check vector for that specific code. One remark is that in the parity check codes, the check vector is 1, 1, 1, 1. And then when you multiply C dot V, basically what you have 1 times B1 plus 1 times B2 plus 1 times Bn plus 1 times D needs to be equal to 0. This is the same thing as, or the equation that we have been working with. So parity check code is a special case of check digit codes where are single error detecting codes. Okay. Let us do few examples. I have written 4 of them here, but I will do one from each one. The rest I will leave it for you. So here, when we have 1, 2, 0, 1, so we have a check vector given, and we have this code vector given. The question is there any single error occurred in this code? Means what? It means that you multiply C to the code vector and check if it is 0 or not. In this case, it will be 1, 1, 1, 1 dot 1, 2, 0, 1. And here's 1 times 1 plus 1 times 2 plus 0 times 1 plus 1 times 1. This needs to be equal to 0 where? In Z3. So this must be checked in Z3. What we have here is 1 plus 2 plus 0 plus 1. This 1 plus 2 in Z3 is 0. And there's 1 here, so this is 1 in Z3. And obviously it's not equal to 0. That means that there's an error here. If it is single error, then definitely there is an error. There is an error, and we can check it using this. Well, let me do this one also. So C dot V, this needs to be V. Okay, V is 1, 0, 1, 5, 2, 2. And we need to check it is 0 in Z6. So let's see. 1 times 1 plus 2 times 0 plus 1 times 1 plus 2 times 5 plus 1 times 2 plus 2 times 2. In Z6, everything is done in Z6. This is 1 plus 0 plus 1 plus 2 times 5 is 10, but in Z6 that's 4 plus 2 plus 4. Now you see this 4 plus 1 is 6. 6 in Z6 is 0. Plus 2 plus 4 is 6, and that's in Z6 0. Well, what this says is that yes, CV is equal to 0, so it means that we cannot, we can say that there is no single digit error in this guy. Well, there might be more than one digit error, but for single one we definitely can say there is no mistake there. Okay, let us do this once. This one says that find the check digit for these vectors. So here it means that you turn u, the vector u, to vector v by adding a digit. But what is that digit? That digit needs to be such that c dot v is equal to 0. So c here is 1, 1, 1, 1 dot 1, 2, 3, 4 needs to be equal to 0. Oh, what is this? Yes, no, this is good. And then this is 1 plus 2 plus 3 plus d needs to be 0. Where? In Z4. And this is, you see, 6, and 6 in Z4 is 2. So 2 plus d is equal to 0. And to get rid of that 2, we have to add both sides by another 2, and you see that the digit needs to be equal to 2. So this is 2. For this one, we turn it to v, which is 1, 0, 1, 4, 1, d. And c dot v needs to be equal to 0. Where? In Z5. So this is 1, 2, 3, 4, 2, 1 dot 1, 0, 1, 0, 1, 4, 1 d. And this is 1 times 1 plus 2 times 0 plus 3 times 1 plus 4 times 4 plus 2 times 1 and plus 1 times d. This guy needs to be equal to 0. So this means that we have 1 plus 0 plus 3 plus 4 times 4 is 16. In Z5 it is 1 plus 2 plus d needs to be equal to 0. So these two you add, this is 5, so that's the 0. So this will give me 2 plus d is equal to 0 in Z5. To get rid of that 2, we need to add both sides 3. So this will be d equals to 3. So the digit we are adding to this vector is 3. This is the basics of these check digit codes. There are 2 special cases that we will work specifically in another video on, but you need to know there's one key equation that must be satisfied, and that is CV, the check vector, dot product by the vector needs to be 0.